Okay, so we wrapped up our section on graphing last hour. That's all we really need to know about graphing for what you guys are going to do. Our next section is probably one of the more powerful sections in this course, and that's on variation. It's talking about how things relate to each other. And if we know the relationship between two values, we can do a lot of work, we can figure out a lot of things without having to have a formula or an equation. So what we're talking about is variation. And as I said, variation just describes the relationship between two values. How does the change in one affect the change in the other? The first type of variation we're going to talk about is called direct variation. Two values that vary directly, if one of them gets larger, the other one's also going to get larger. Not necessarily by the same amount, but by a proportional amount. Maybe twice as much, maybe half as much, or a third as much, or whatever. But if one gets bigger, the other one must get bigger. Or the other side, if one gets smaller, the other one must get smaller. Again, not necessarily by the same amount. There are two possible ways of writing this equation. Either you can write it as y is equal to a constant times x, which is the one that we're going to use most. Or we can write it as y over x equals a constant. Y over x, we can think of that as our slope. Rise over run, vertical over horizontal. In other words, it is a constant ratio, a constant slope. If we are told that x varies directly with y, what's that telling us? Well, that is telling us that y equals kx. X varies directly with y, or y varies directly with x, either way. Now that equation itself, y equals k times x, is a generic equation. It doesn't help us much. It's more useful if we know the value of that constant k. And in order to do that, we have to have some sort of an initial condition or initial set of values. In engineering, we called it an initial condition, or a known state, a known condition. So let's say we're told y varies directly as x, and y is 72 when x is 24. Now this is telling us two things. Right here, y varies directly as x is telling us, once again, y equals kx. Y is 72 and x is 24 is allowing us to find k. So we're going to put the numbers in here. Y is 72, so I'm going to replace y with 72. K is still k. I'm going to replace x with 24. And now I can solve for k. I'm going to solve for k by dividing by 24. 72 divided by 24 is 3. K equals 3. So that tells me that the relationship is really y equals 3 times x. So I use that relationship. I know how they vary, how they're related to each other, and an initial set of values to create an equation. Here we're being told y varies directly as the square of x, and y is 125 when x is 5. So now y varies directly as the square of x. That's our first piece of information. So this is not going to be y equals kx, it's going to be y equals k times x squared, the square of x. Now, I'm going to put in for y 125 equals, still going to be k, and x is going to be 5. So it'll be 5 squared. What's 5 squared? 25, right? So 5 squared becomes 25. So 125 equals k times 25. Then what do we have to do? Divide by 25. So 5 equals k. So what's that tell us? We'll bring that back up here with our original generic equation, and we're going to replace k. So y equals 5 times x squared. Not so bad? So y varies directly with x. And y is 36 when x is 4. Find y when x is 7. So we've added a step here. But we're starting out the same. Y varies directly with x. What's that telling us? Y equals kx. That's our form of equation. Next, y is 36 when x is 4. That's telling us to come back to this equation and put what in for y? Y is 36. Good. Equals k, and what are we going to put in for x? 4. X is 4. So 36 equals k times 4. What do we do with that? Solve for k by 4. So 9 equals k. So that tells us that this relationship here, k is 9. So it's really y equals 9x. Y varies directly with the square root of x, and y is 45 when x is 9. Find y when x is 49. So again, y varies directly with the square root of x. So y equals not k times x this time, but k times square root of x. Perfect. Now, what am I going to replace the y with? Y is 45. K times the square root of, what am I going to replace x with? With 9 at first. No, getting this stuff out of it. So now we got to take the square root of 9, which is 3. So 45 equals k times 3. And then divide by 3. So k equals 15. So that equation, y equals k times the square root of x, is y equals 15 times the square root of x. I just realized I never finished the last problem. Yeah. The third step. Let's finish this one, then we'll go back. It's Friday. So find y when x is 49. That's telling me I have to take this equation now and put 49 in for x. So it's 15 times the square root of 49. What is the square root of 49? 7. So y equals 15 times 7, or 105. So y is 105 when x is 49. That's the part I forgot in the last problem. Yeah, this is saying find y when x is 7. So I put 7 in for x. 9 times 7 is 63. Sorry about that. Why I didn't finish it? Yeah. It's Friday. I'm sitting on a beach somewhere, having a few drinks. Yeah. I'm delusional. I'm probably going to go home and go to sleep anyway. Y varies directly as x. And y is 48 and x is 12. Find y when x is 11. Try that one in your notes. We'll discuss it in a minute. So, first step, y varies directly with x tells us what? Y equals kx. Good. Then what? Perfect. We put in 48 for y and 12 for x, and then divide by 12 to get 4 equals k. So that tells us y equals 4x. Good. And then y equals 4 times 11. So y is 44. Cool. So that is direct variation. Our other type of variation that we can have is inverse variation. Inverse variation is when one number gets larger, the other number must get smaller. Again, not necessarily by the same amount, but proportionally. So, there are two forms for this. One is y equals k divided by x. That's going to be the main form that we use. But the other form that can be used is y times x equals a constant. It's not, the direct was a constant ratio. This is a constant product. So if we are told y varies inversely as x, what that is telling us is that y equals k over x. So if we're told y varies inversely as x, and y is 7 when x is 8. That's telling us two things. Y varies inversely with x means y equals k over x, just like before. Y is 7 when x is 8 is telling us we put 7 in for y, 8 in for x. Now how do we find k? Multiply by 8. Multiply by 8 cancels that out. 7 times 8 is 56. So k equals 56. So the equation becomes y equals 56 over x. So find for me the equation. If you're given y varies inversely as x, and y is 13 when x is 5. Find that relationship for me. So y varies inversely as x, means y equals k over x. Y is 13 when x is 5, means 13 equals k over 5, and then what do we have to do? Times 5. Good. 65 equals k. So our relationship is y equals 65 over x. Not so bad? Okay. So y varies inversely as x. And y is 16 when x is 3. Find y when x is 12. So again, we've got three parts now. Y varies inversely as x means what? Y equals k over x. Then what do we do? Okay, so we put in 16 for y and 3 for x. We solve for k by multiplying by 3. So 48 equals k. So that defines our relationship now to be y equals 48 over x. Okay, now we put in find y when x is 12, so we put in 12 for x to get that y would be 4. Questions? This is not so bad, is it? Till next week. Y varies inversely with the square root of x, and y is 72 and x is 16. Find y when x is 81. So where do we start? Well, y varies inversely with the square root of x. What's that tell us? Y equals, inversely means k over, but not over x, it's over square root of x. Then what? We put in 72 and 16. So 72 equals k over the square root of 16. And then we square root 16, so 72 equals k over 4. And then multiply by 4. So 288 equals k. So what that's telling us is y equals 288 over the square root of x. Then what? We put 88 or 81 in for x. 288 over the square root of 81. And then, what's the square root of 81? 9. 288 over 9 is 32. So y is 32. What do you think? Not terrible? Y varies inversely as x. And y is 8 when x is 12. Find y when x is 16. Try that one in your notes quick. See what you come up with. A little bit of this, a little bit of graphing.
Is that next week?
Next week. There's gonna be like 2 or 3 questions on this stuff. You like this stuff? Yeah, I do it. It works. So. Good. So y varies inversely as x. Means what? Y equals k over x. Okay. Then what? Y is 8 and x is 12. And then multiply by 12. So 96 equals k. And then so y equals 96 over x first. And then we can put in 16 for x to find out what y is when x is 16. So 96 over 16 is 6. Y is 6. Any questions? So why did I say that this is one of the more useful tools in math? In engineering work, it's tremendously useful. Let's say that a 24 square inch beam can withstand 288 or 2,880 pounds of force. What size beam is required to hold, oh shoot, you know it's been a long week when the internal calculator shuts down. 4,320 pounds. Now this one doesn't come right out and say it's inversely related or directly related. And most of the time, the applied problems aren't going to say that. You have to figure that out for yourself. But looking at this, do we know whether it's inversely or directly related? It's directly. How do we know that? Well, if you increase the force on that, do you have to get smaller or bigger? It has to get bigger, right? So more force takes a bigger beam. So we know that if the force gets larger, the size of the beam has to get larger. So this is direct. So 24 square inches and 288 pounds. Does it matter which one I make, X or Y? Not really. I can let 2880 be Y. Let's just do this. But Y equals KX. Now Y equals KX is the generic form of a direct equation. So I'm going to put in this. I'm going to put in the force equals K times the area. The 24 square inches is the area of my beam. Now I can put in the values. The 2880 goes in for the force, and 24 for the area. And I'm going to divide by 24 to get what? 120, is that right? 120 is my constant. So that's telling me that Y equals 120 times X, or the force equals 120 times the area. So if the force is 4320, that has to go in for F, and for Y. What's the area have to be? Well, this is a little bit different because I can't just multiply or whatever. I'm just going to have to divide out 120. 4320 divided by 120 is 36 is my area. So that beam would have to be 36 square inches. I didn't have a formula for the stress. I didn't know what the unit stress for the lumber was or whatever. But because I know it's a direct relationship, I could find an answer, get a result. Now I said it didn't matter which one we made X or Y. Would it have changed this problem if instead of saying force equals K times area, if I had said area equals constant times force? It would change the appearance, but it would not change the answer. Because here I'd put in 24 equals K times 2880. And I would solve that by dividing by 2880, which is going to give me 1 over 120 equals K. So now the area equals 1 over 120 times the force, and I would put in the area equals 1 over 120 times 4320, which is going to give me what when I multiply them out? 36 inches. Square inches. So you can see the calculation, the process looks a little different, but the answer is the same. So it doesn't matter which one you pick to be which. Now you might be thinking, that's great, but we're not designing beams. Well, let's say that you have several patients. Well, let's do this. Let's say you have a patient that comes in and you estimate the weight at 45 kilograms. So the doctor orders 135 milliliters of medication to be administered. After checking the weight, you realize that this patient is a lot more solid than they look. The actual weight is 65 kilograms. How would you adjust the dose? What would the new dose be? Well, is this a direct or an inverse relationship? Should be direct. The amount of medication should increase if the weight increases. So, the dosage equals a constant times the weight. So I'm going to put in, what was the dose? 135 equals K times, what's the weight? 45. Now, if I wanted to put units in here, I could have 135 milliliters and 45 kilograms. So this next step, K, is going to make a little bit more sense. We're going to divide by the 45 to get rid of it. So what I'm getting here is that my constant K, 135 milliliters divided by 45 kilograms, is 3 milliliters per kilogram. The K in this case is actually your dosage per kilogram. So now my dosage is going to equal 3 times the weight. We know that that's milliliters per kilogram. So now my patient, who is actually 65 kilograms, 3 times 65 is 195 milliliters. So instead of 135 milliliters, the correct dose would be 195 milliliters for that patient. Any questions? Okay. For those of you in the ADN program, you're going to have a chemistry requirement, whether you've already had it or not. A big application in chemistry is the ideal gas law. A very simplified version of the ideal gas law is at standard temperature, as long as the temperature does not change, the volume of a gas varies inversely as the temperature. Or sorry, not temperature. I said temperature is constant. Varies inversely as the pressure. Sorry about that. If the volume is 4,800 cubic centimeters at 16 kilograms per centimeter squared. Find the volume at 12 kilograms per centimeter squared. So where do we start? Well, volume of gas varies inversely with pressure. Excuse me. So V equals K over P. So now what do we put in here? Well, what goes in for V? Volume is 480. P would be 16. Now what? We're going to go times 16. 480 times 16 is what? 7,680, is that correct? Okay. So what this is telling us is that the volume is 7,680 over P. And we're, of course, asked to find the volume at 12 kilograms. So the pressure is 12 kilograms. So V equals 7680 over 12, which is going to divide out to give us what? 640 centimeters cubed. Not so bad. So, volume varies inversely as pressure. Volume is 8 cubic feet when the pressure is 30 pounds per square foot. Find the volume at 40 pounds per square foot. In your notes, give that one a shot. Somebody's in a really good mood out there, aren't they? It is Friday. Well, I can see there's maybe 30 people in the building right now. Volume varies inversely as pressure, so V equals K over P. What goes in for V? 8. Very good. What goes in for P? 30. So we solve for K by multiplying by 30. So 240 equals K, giving us that volume equals 240 over P. Then what? Volume equals 240 over 40, which is 6 cubic feet. How many of you had that one right? Cool. You know what you did? Had it? Okay. A patient with a body surface area of 0.85 square meters is prescribed 340 milligrams of medication. How much medication would be needed for a patient with a body surface area of 1.10 square meters? Give that one a shot in your notes. So direct or inverse? The body surface area goes up. Should the amount of medication go up or down? Should go up. So this is direct. So the dose is equal to a constant times the BSA. We're just going to go B for BS, body surface area. So then we'll put in dosage is 340 equals K times body surface area is 0.85. 0.85. So now what? Divide by 0.85, which gives us what? 200? 400. There we go. 400 equals a constant. So that tells us that the dosage is 400 times the body surface area. So now, what's the dosage for a patient with 1.10? So it's 400 times 1.10, or 440 milligrams of medication. What do you think? What's that? In 12 hours, a patient receives 1,600 milliliters through IV. How long will it take for a patient to receive 4,000 for that same patient? So you receive 4,000 milliliters. Which says that patient received 4,000 milliliters. Figure that one out. Well, I use this example because we could approach this example in several different ways. We could approach this with the variation that we've just talked about, saying that the amount of fluid infused and the time are directly related. Volume equals the constant times the time. So then it's 1,600 milliliters in 12 hours. Dividing by 12 What does K have to be? What's 1600 divided by 12? 133 1/3 equals K. So that means the volume is 133 1/3 times the time. It's asking how long to infuse 4,000. So 4,000 equals 133 1/3 times T. Well, to solve that, we're going to divide by 133 1/3 to get 30 equals T, 30 hours. How many came up with 30 hours? No? Anybody? 1? 2? Okay. Well, okay, that helps. I feel a little bit better. The other way we could have done this is we could have gone back to what we were talking about before. If you think of this on a graph, at the start, the patients receive 0 milliliters. So the y-intercept would be 0 milliliters. And then, if we put this line out here, at 12 hours, they've received 1,600 milliliters. So the slope is 1,600 milliliters per 12 hours, or 133 1/3 milliliters per hour. So the equation would be y equals 133 1/3 times x, or the volume equals 133 1/3 times the time. And then put in 4,000 for the volume and solve for T, which is still going to give us 30. Any questions? Okay, some pages in your book. On page 226, 1 through 15, if you just do the odds, should be adequate there, working on finding slopes. I don't know if I gave it to you last time, so I'm going to do it again. 221 to 222 is 1 through 15 the odd as well, just in case I didn't give that one to you last time. And then page 231 through 235 is just looking at graphs, trying to identify what they mean, and reading graphs, tracing them if you know what the x-coordinate is, what's the y-coordinate, and so on. And then on this variation stuff, page 240 through 241, 1 through 21 the odds. And remember, your Unit 4 test is next week, Friday. I know that's terrible timing, having it literally hours before you start the Thanksgiving break, but that's how it works out. So you guys have a great week, and we'll see you next Friday.